In this lecture, we're going to be talking about the phases of matter, the three phases of matter that exist on this planet. And they are solid, liquid, and gas. And what we want to talk about is what is going on with the matter within those three different phases. How is the matter, or the atoms, or the particles, how is it actually moving? So when we're talking about solids, then there's not a whole lot of movement. Solids have a fixed shape, and the motion, their particles are actually vibrating. I know you can't feel it, but they actually are vibrating. It's a very, very slight vibration. It's a very small movement, but that is their movement. Now, liquids can be poured, and they also take the shape of their container. And this is because their particles are actually flowing over one another. But they're still connected. Now, in a gas, gases are going to fill their environment. E&V is environment. They are going to fill their environment. And this is because gases, the particles are moving very fast. And they actually often are bouncing off of one another. So, the three phases, solid, liquid, and gas. Within solids, solids have a fixed shape, so the particles are just slightly vibrating. Liquids can be poured, they take the shape of their container, so the particles are actually able to flow over one another. And gases are going to fill their environment, whatever environment they are in, they are going to fill that, because their particles are moving around very fast, and they're actually bouncing off one another. So now let's talk about some terms for phase changes. So a phase change means when something changes from a solid to a liquid, or a liquid to a gas, or back and forth. So let's talk about the phases freeze and melt. These two are opposites. Freeze means to go from a liquid to a solid, and melt is the opposite. Melt is going from a solid to a liquid. Now, evaporate and condense are opposites as well. Evaporate is going from a liquid to a gas, and condense, or condensation, is to go from a gas to a liquid. Sublimate and deposition are two that you may not have heard of before. Sublimate is actually when you skip the liquid phase. So sublimate is going straight from a solid to a gas. Dry ice is a really good example of something that sublimates. It goes straight from a solid to a gas. And deposition is the opposite of that. So it goes from a gas to a solid. And snow is a good example of something that does this. Snow is actually frozen water vapor. So water vapor, which is a gas, goes straight from being water vapor into being snow, which is considered a solid. So now we need to talk about how temperature is going to affect the motion of those molecules, and how temperature can actually cause phase changes. So first we're going to talk about an increase in temperature, and that's what this arrow up means. That a temperature increase causes the particles to speed up because there is an increase in the amount of energy within them. So if we have a solid, so now the particles were originally vibrating. So what happens is when that energy increases, when that temperature goes up, that vibration actually speeds up. And those particles can actually begin to break apart from one another and flow over one another, or they can become a liquid. So in a solid, so the vibration increases to the point the solid melting or becoming a liquid. Now, when a liquid, we had the particles were flowing over one another, but they were still connected. So in this case, that process, the increase in temperature, the increases in energy, causes those particles to speed up even more. So they speed up even more to the point where they break apart and they can become a gas or a vapor. So liquid, so the particles speed up and they can break apart, or evaporation is occurring and the liquid becomes a gas. For gases, gases are actually a little bit interesting because there is another phase for them to come in. So you do have, when you have an increase in temperature, you do have an increase, I should do the arrow up, increase in the particle motion. And actually what can happen here, because the particles are going to speed up, they are going to spread apart. And you can actually have the density of the gas is going to decrease because you're going to have fewer particles in the same space. This is something that we'll talk a little bit more about later. But I do want you to know that if there's an increase in the temperature of a gas, that the particle motion can increase to the point where those particles will spread out and it will actually cause the density to decrease. So now what happens when there is a decrease in temperature? So here, arrow down means decrease. So this causes the particle motions to do the opposite. So this causes them to slow down because there is a decrease in energy or a reduction of energy. So when we're talking about gases, where their particles were moving around really, really fast, they were bouncing off of one another, now those particles begin to slow down and they move closer together. And they can actually begin to condense, which is really they are connecting to one another, and it can become a liquid. For a liquid, where the particles were able to flow over one another, if you have a decrease in temperature, the particle motion will begin to slow down to the point where it actually becomes locked in place. So the particles lock in place, so they can no longer flow over one another, and this would be called freezing, or the liquid would become a solid. Now, what in the world can happen to solids? Not really much. Solids, the vibration would slow down. But it's not going to change phase. It's not really worked down. It's not really going to change phase because there isn't another phase. But you do have a slowdown in the vibration of those particles.